Hello everybody, welcome to my channel Chemie 19 Fundamentals by Abhi Chakravarti. So today's video we are going to discuss about Introduction to Automatic Process Control and Robotics in Food Industry. So here in this video we will talk about the importance of artificial robotics in food processing and post-harvest engineering in agricultural and food engineering specialization. We see here 4 different types of robots. Actually, the robots are of 15 different categories. It is not easy to define what robots are, and it's not easy to categorize them either. Each robot has its unique features. Here are 15 categories we need to classify robots. They are based on aerospace, like drones, unmanned aerial vehicles, consumer, disaster response, drones, education, entertainment. In entertainment we are having Disney's theme park, Robotics, exoskeleton is the another category where robotic exoskeleton can be for physical rehabilitation for enabling a paralyzed patient walk again. Now we are having humanoids, Honda's Eskimo, or like Geminoid robots, industrial robot, a manipulated arm, like unanimate, grandfather of all factory robots, medical Da Vinci robot, which is a surgical robot and bionic prosthesis, as well as robotic exoskeleton. So, if we categorize the robots, we are having food serving robots, we are having pick and place robots, we are having Delta robots, and we are having pick and place robots in food processing. So, coming on to the main category of robotic classification, we are having Cartesian, where we find 3 linear motions, that is an X, Y and Z axis, which are prismatic in nature. That means they have sliding movements of variations. Now we are having linear orthogonal system. 3P is a fix for Cartesian system. The Gantry Robots, in the Gantry Robots they are similar in kind of Cartesian robots, but we give an extra support to the robots in the form of one pillar or like this. So part of Cartesian system robot can carry high payload values, higher accuracy and less number of points. Now 2 important factors for a robot are reach and stroke, are specifications of a robotic manipulator, which are if we see on the basis of a MCQ, what is the reach and stroke of a robot, we find that stroke is equal to reach. If stroke is equal to reach, if stroke is less than equal to reach, stroke is greater than or greater than equal to the reach. If we go on the concept part, that means that robot reach is a measure of how far the robotic arm can reach when it's completely outstretched. The horizontal stroke is defined as the total radius distance the wrist can travel. This reach is always greater than equal to stroke. So robot reach is a measure of how far the robotic arm can reach when it's completely outstretched. The horizontal stroke is defined as the total radial distance the wrist can travel. Reach is always greater than or equal to stroke. Now, the word which is derived from Czech noun robota meaning labor is an accomplishment of Capek Folder brother, the cubist painter and writer Joseph Capek. The first word first appeared in the play of RUR published in 1920s. If we come to the 3 law of robotics, often shortened to the 3 law known as Asimov's law, or set of rules defined by science fiction author Isaac Asimov, he proposed laws as the zeroth law. The zero law is zeroth law. A robot may not injure humanity or through inaction allow humanity to become to harm. Law first states that robot may not injure a human being or through inaction allows a human being to come to harm unless this would violate the higher order law. Law 2. Coming to law 2, which is a robot must obey orders given to it by human beings except when such orders would conflict with a higher order law. Law 3 is robot must protect its own existence as long as such protection does not conflict with higher order law. Now if we see here, we find different categories of robots. One is spatial station, another is pick and place, one is spider or delta robots. These robots are basically have the servo motors, rotating stations above a fixed plane of reference, and the food packaging robots in the lower left diagram are food packaging robots and plant handling robots. Now if we come to the next slide, here's an assignment for you. It's a very interesting assignment. If you see here, design pick and place robots. So what you need to go through is that to design a pick and place robot, formulate forward and inverse kinematic algorithms. These forward and inverse kinematic algorithms are an integral part of a robotic design. So we will come to this discussion later on in our coming tutorials. We learn to formulate an optimization problem, integrate and execute the problem. So we design pick and place robot with the help of the softwares. This is your task. So when we go to robot pick and place with RGBD sensor, first of all we have to do trajectory planning, detect and estimate positions of objects. System integration is there. We find robotics optimization is there. Computer vision, machine learning is there. Control logic, co-simulation, code generation is there. So where do we start? So first of all, we plan with the motions, joint trajectories, motion planner is there, object detector is there, state control, robotic simulator is there. So after this, we find that motion planner and object detector holds on to the state controller, robotic simulator. Now for trajectory planning, we detect and estimate position of objects. System integration is there, initial pose, refer to final pose, joint limits and obstacles. Motion planner is there and joint category is there. If we look onto the workflow chart, we present this represent the robot X0, solve inverse kinematics for the XT0 and XFT. Robot simulation is there. Then we solve optimization for problem, then spline parameters. Now what are linear and cubic splines? Splines are basically the path or the trajectory taken which is the shortest path to basically grab an object or to place an object. It should be the shortest possible path available, followed, not be the longer path. Suppose we have to pick a pen from a table and keep it in our pocket. We do not take the pen from the right hand and go all the way around, circle it and then put it in our pocket at the left side of our shirt. We find the shortest route possible. In a similar manner, there are algorithms which are known as splines, which are also used in robotics to basically find out the shortest possible route. So higher order polynomial interpolation is really used for practical purposes because of a polynomial vehicle that is high swings of interpolating polynomials between the data points. Most of the computational algorithms use the idea of spline, that is piecewise interpolation. The MATLAB functions interp and x1 y1 xy x1 linear and interpret xy xi. Spline are also based on linear and cubic interpolation. The linear spline sends a set of line segments between two adjacent points. If we suppose the points as vk and vk plus 1 ik plus 1, the equation for each line segment can be immediately found in a simple form like this: ikv is equal to ik plus 1 minus ik into v minus vk divided by vk plus 1 minus vk, where vk plus 1 is spline applied to voltage current data for a Zener di-interpolating algorithm produce the following picture. Now if you look to the spatial frames, the figure shows the position and orientation of the frames A, B, C in space. Could you find out if the transformation matrices, if you have to form T of AB, how can you get it? Multiplying transformation of T of AD into DB. So how we can find out TAD and DB? These are all homogeneous transformation matrix or HTMs, which we will see later. So by multiplying in this manner, we can find the transformation matrix for placing moving from A section to B section. Similarly, the object pulling up, here we see an example. A camera is attached to the robot and effective to observe the object in position, the end effector in the right position. 4 reference frames are there, that is A frame, B frame, the spatial frame, the object frame D frame, the end effector frame B, and the C frame with which the camera is attached with the end effector. So if we see here, if we shows the position and orientations of A, B and C in this space. Now when we come to robot classifications, we are having cylindrical robots. So cylindrical robots, we are having one twisting link, two sliding motion, that is two prismatic, one revolute joint, it is called TLO joint, transverse longitudinal and orthographic joint. Work volume. So if we go to work volume, the work volume or work envelope is the three-dimensional space in which the robot can manipulate at the end of the list. Work envelope is determined by the number and types of joints in the manipulator, the ranges of various joints, and the physical size of the links, radius Z and phi. Now if we come to spherical robot, it is composed of two revolute and one prismatic joint. So here it is one revolute, this is the second revolute, and this is the third one, is the prismatic joint, and is represented by this diagram. If we come to articulated robot, it has a work envelope similar to a human arm. This is an example of an articulated robot. It is having 4 revolute joints, 1, 2, 3 and 4, and one rotate end effector. So this is one end effector which is having the object, and the 4 revolute joints are moving. Now if we come to SCARA or selective compliance assembly robotic arm, this is basically the example of a SCARA robot which is having 3 revolute joint and 1 prismatic joint. So J1 is revolute, J2 is also revolute, J3 is also orthogonal joint. So 2 revolute joint and 1 orthogonal joint. It's used for like the tightening of screws, assembly and disassembly. Now we come to the another important category of robots which are known as delta robots. If we see here on the base platform, all the motor, reducer and actuating arms required to make the system more agile and less heavy. So they are known for high speed and high acceleration. The design is thwart the resistance period and other types of industrial robots. Most industrial robots have motors located in the robot arm, making them conducive to heavier payload applications. Now if you go into the classification based on degrees of freedom, we find that degree of freedom when it is less than 6, it is called constraint manipulator. There are several types of robotic manipulator. These types are very based upon the combination of joints and include Cartesian, cylindrical, polar, articulated, SCARA and delta configurations. Based on actuator, hydraulic actuator robotic systems are there. When the degree of freedom is equal to 6, we call it as a spatial manipulator. The pneumatic actuated robotic systems, when degree of freedom is greater than 6, it is called redundant manipulator. Electrically actuated robotic system. So here are some of the slides. If we go through the other part of the degrees of freedom in robotics, so there are a lot of things to basically learn about. If we come to our main part which we are discussing now, so we will go with actuator parts. So actuators can be categorized by the energy source they require to generate motion. For example, hydraulic actuators use liquid to generate motion, pneumatic actuators use compressed air to generate motion, electrical actuators use an external power source such as battery to generate motion. Now classification based on control system. If we see here classification based on control system, one is open loop, no feedback, no sensor, low cost, non-servo motor, stepper motor is there. Application is loading and unloading take place, spot welding. Closed loop, we are having feedback sensors, servo motors, command, result, design and error. Closed loop, feedback sensors, servo motors, etc. are there. Now if we go to a one-page classification of different kinds of robot, we find that Cartesian robot is there, cylindrical robot, spherical, articulated and SCARA. If we consider the arms basis, we are having 3 linear motions in Cartesian. Work volume is cuboid. Advantages can carry high load, simple operation, high speed, less cost and high accuracy. Similarly, if we go for SCARA, we are having twist, linear and rotary arm, donut shape and kidney round shape is the work volume, high speed, greater for assembling, C for assembling, packaging and microphone loading. And then we come to automated food process control. They are having thermocouples, we are having other aromatic signal, which we use physiologic controller, the noble food systems. So that's all for this video, and we will share with you the some parts of our the next topic, which will be our sensing technology during the food drying process. Till then, thank you.